Welcome back, ladies and gentlemen. As promised, we are now going to be discussing the challenges facing the Arabic language NLP and possible solutions to them. Obviously, since we are in the we're doing the Voice Tech Summit Middle East region, we are focusing on the Arabic language and how we can enhance voice technology specific for Arabic language users. Our speaker is Mahmoud Daif, who's a master's student at Hosei University. He will be talking to us about the introduction to Arabic language and its various dialects, and voice agents and different components for building voice agents and how to tackle each challenge specific to the Arabic language. A little bit about Mahmoud Daif before we hand the stage over. He holds a PhD in distributed computing from the Tokyo Institute of Technology in Tokyo. And his research interest includes semantic systems, machine learning, health informatics, and of course, web application security, among many other varied interests. So, Mahmoud, this is a Voice Tech Summit Middle East. You have an audience from the Middle East as well as all over the world. The audience is very keen to hear what you'd have to say about the challenges facing the Arabic language NLP and how we can overcome them.
Hello everyone. So sorry we had can you hear me? Okay, تمام. Okay, I can see it now. Okay, تمام. Okay, sorry again. Oh, it's done. Okay, let's get started. تمام, next slide please. Okay, so first, I'm sure that most of you already know about the Arabic language, but I'll give some quick overview for the non-Arabic speakers with us. So, Arabic is the official language of 22 nations of the Arab League, and also it has some official recognition in some other countries, but yeah, it's mainly the language spoken or the official language of the Middle East, and is spoken by as many as 422 million peoples worldwide, making it the fifth most popular language, and is one of the 6 official languages of the United Nations. And this gives you an idea of how big and important Arabic is, and there are 3 different kinds of Arabic, as we will see in the next slide. So, next slide, please. So there are 3 types of Arabic. So the first one is the modern standard Arabic, which is the official language used in government documents, media, news, and books, and so on. And we have the classical Arabic, which has survived 15 centuries, mainly existing in religious scriptures such as the Holy Quran and old poetry. And we have the dialectical Arabic, and this is the mainly a spoken language that varies between one country to another, and even within the same country, it varies from one region to another. And now it's the language that's mostly used on social media. The main big categories are Egyptian, Maghrebi, Gulf, Iraqi, and Levant, but I mean, these can be broken into many, many other categories. So, yeah, next slide, please. Next. So now we will introduce the Arabic alphabet and writing. So Arabic is written from right to left, unlike, for example, other languages like English. And it has 28 characters, 13 with dots and 15 without. And each character can change its shape depending on its location in the word, whether it's beginning, middle, end, or alone. And this can give you some contextual information. And we have 3 short vowels, or we call them diacritics. They can be written above or below the word, and they also change the shape of characters. The diacritics are usually optional. Native speakers generally don't write them or don't need them, but they can cause some ambiguity for non-native speaker and for natural language processing, and we will talk about this later. So next slide, please. So now let's talk about Arabic natural language processing, how it evolved over the years, and where are we currently. So first, there were some static methods that some of them are fairly popular nowadays. An example are the dictionary-based or lexicon-based methods like Arasenti, which is sentiment lexicon for Twitter. Still, these methods are somewhat popular, and another example of static methods are rule-based methods like the Hosei stemmer. So what's stemming? Stemming is basically transforming the verbs or nouns to their root form. So, or this is the goal by removing prefixes and suffixes. For example, like verbs like connect, connected, and connects are all gets transformed to connect. So, I mean, this is very old and like a rule-based method, but the Hosei stemmer is still fairly popular, and I used it as one of the baselines in my research. Another example is Mira, named entity recognition for Arabic. Basically, it's a combination of rule-based and dictionary methods for named entity recognition. And named entity recognition is we want to label the nouns as person, organization, or location. And after that, the natural language processing methods for Arabic has evolved into, as we will see in the next slide. Next slide, please. Into some statistical methods like n-gram language models, and they capture the probability of occurrence of certain words or certain words together, and they are used in many applications. For example, like speech recognition or text classification. Again, still fairly popular. Also, another example is hidden Markov models. some would argue it's a machine learning model, but it's actually officially a statistical method, and it's very popular in speech recognition as well. And then, the next step was, as you'll see in the next slide, the machine learning methods came. So basically, for NLP, machine learning methods can be classified into classification or clustering problems. So now these are still the most popular methods used for Arabic NLP. So we have like techniques like support vector machines and logistic regression. They mainly used to solve classification problems like sentiment analysis or topic categorization, but also can be applied to other techniques like part of speech tagging or Arabic diacritization and so on. And we have clustering based methods. So basically, so the first methods, they need some kind of labeled data, but the clustering based methods, you can say that they act as unsupervised machine learning technique to discover patterns within data. Like k-means clustering, for example, can be used to discover topics if you have some kind of a large amount of data and it's not labeled or annotated. And then came the era of deep learning. So deep learning now is achieving mostly state-of-the-art techniques for many languages, and the research for deep learning is blooming nowadays. But unfortunately, for Arabic NLP, it's still lagging a lot behind compared to other languages like English. But I would talk about there have been, even for Arabic, there have been a very good progress in the language modeling part. Like, for example, I would mention Arabic word embeddings. So basically, what's a word embeddings? It's the representation of words as a continuous numerical vectors, and this supposedly can help capture some of the context information. So Arabic has been applied to many research problems like named entity recognition, text classification. It has been around since 2017, and it solves so many of the problems of using like classical machine learning for Arabic. Another method I'd like to talk about is character embeddings. So, previous slide, please. Yeah, so I would like to talk about our own research, which is Arabic document classification using image-based character embedding. So we do the natural language modeling on the character space, and we convert Arabic images into characters. You might be interested to look into this method. It can solve some of the problems associated, as we will show later. The character method solve some of the challenges with Arabic, as opposed to like wrong spelling or inconsistent spelling and so on. And then this year we have Arabert. Actually, transformer-based methods have been revolutionizing the NLP for many languages, and Arabert was released this year. So, I mean, like one of the most influential papers for NLP recently was the attention is all you need. And basically, these attention methods, they try to focus on only the important parts in text when doing specific tasks like sentiment classification, for example. And Arabert was applied to the Arabic language, and when applied to certain tasks like, let's say, named entity recognition, it achieved state-of-the-art results, and it has so many potential because it allows to process larger amount of text in a fast way, and you could just do transfer learning by training on smaller amount of data for a certain task and achieve very good results. So it's very recommended if you're doing some Arabic NLP. So next slide, please. So how does this all relate to voice agent? Actually, voice agents contain like a lot of complicated and big NLP problems. So this is like the general architecture of a voice agent. Generally, you have things like automatic speech recognition, natural language understanding, or dual tone multi-frequency tone recognizer. And dual tone multi-frequency tone recognizer is like a static message, that like if you tell the user, okay, if you want to go to this section, press 1 or 2. So it's, like static input. And, automatic speech recognition is converting speech to text. Natural language understanding is understanding the entity or intent of the user. And then the dialogue manager would understand the context and then generate some text or some pre-recorded audio, and you need to do text-to-speech. So it contains a lot of the NLP process, and by design it has many of the challenges associated with Arabic NLP. So next we will talk about some of those challenges, and we will try to talk about how to tackle them. So next slide, please. So I'd like to talk about some general challenges. For example, if you did some Arabic NLP, you would know that the first problem that would face you is the availability and the size of data. Usually you don't have as many data as compared to other language, or domain sensitivity. Maybe you want to do a named entity recognition system. You have a lot of good data for politics. But for example, if you are developing a voice agent for football and you want to do some named entity recognition for the football domain, it will not perform as well, of course, if you apply it to other domain. Also, the quality of annotations. I mean, humans don't usually agree on certain tasks, so when doing annotation, this has to be certainly taken into mind. I mean, doing like these quick and cheap annotations would only result, in bad output, because your algorithm can be only as good as the data you have. So it's usually a common practice to have multiple people doing the annotation, doing some kind of majority vote. Also, another problem is the lack of research in Arabic compared to other languages, especially in the deep learning field. We are still, in the very early phases, but there is definitely a lot of potential. So next slide, please. And okay, these were the general challenges. Now I want to talk about some certain specific cases that if you are doing, some Arabic NLP on things like social media, you would definitely come across. Like there is a lot of spelling errors. For example, the Qatar Arabic Language Bank made a corpus for about 2 million spelling mistakes and their corrections from Al Jazeera comments. And they found that even some of the machine learning systems were trained to produce these errors. So this is a very good resource, I think, and definitely this corpus of the spelling mistakes and their correction could be useful in many cases. And with another problem that's similar to spelling errors is, as we'll see in the next slide, is the inconsistent spelling, especially if you're dealing with dialectical Arabic. For example, in Egyptian Arabic, if we want to say, I didn't go, we can write it in all these 3 forms and they could be like all correct. And this is not a spelling mistake, it's just inconsistent spelling, because, the dialectical Arabic was mainly a spoken language. It's not a written language. And this problem actually, it has a very good solution. So is trying to do the language modeling on the character level. So working with character level models and character level deep learning models could really surprise you if you're working with such data like social media data with a lot of spelling mistakes and inconsistent spelling. It could be a really useful tool. And generally speaking, I know that the deep learning is still in its early phases, but yeah, we really need to try it, and yeah, you'd be surprised by a lot of problems that it could solve regarding the complicated morphological analysis also, as we will see in the next slide. So next slide, please. So another problem is Arabic dialects. Still, that when you're developing a voice agent, the text or the vocabulary between different dialects is very different, and even the personality. So voice agents, for example, need to give it a personality. So personality, for example, between Egyptian Arabic and Levant Arabic is very different. Also, the words and doing speech recognition for this is very different. Most common solutions for this is many people treat the different dialect as a separate language. This could definitely be a good solution. For example, Amazon Lex, it has some voice abilities, but it doesn't support, and it only supports the Gulf dialect. So the other challenge is complicated morphological analysis. Arabic is a very rich morphological language, and in the classical machine learning, when doing the morphological analysis, it was very time consuming, and you needed a lot of models to do this, not just one model. But in 2015, so Zhang introduced the character level CNN, where he assumed that the treated the text as an input signal of raw characters, and then the character level CNN would learn all the morphological analysis for a specific task. And ever since then, this idea have been introduced in many other deep learning models. So, deep learning could really be useful here when working with Arabic due to its very rich morphologically, and allowing the deep learning network to learn the language morphology by itself could be very useful. So next slide, please. So with this I conclude my presentation. We talked today about the Arabic language. We mentioned how the natural language processing for Arabic evolved from the statistical methods, then machine learning methods, which are still very popular. We talked about deep learning methods, especially for language modeling part, and how they could be useful to solve some of the many challenges you will face with Arabic NLP. So thank you so much for listening.
All right, thank you very much, Mahmoud, for coming and being a part of the Voice Tech Summit Middle East. I'm sure the audience found your presentation very interesting and insightful. If any of our audience members would like to interact with Mahmoud post his speech, he is available in the VIP section and the other networking areas. So he is available there. And thank you very much, Mahmoud.
Thank you so much.
So we will slip into a short 10-minute break right now. And when we come back after 10 minutes, we are going to continue with a panel discussion on how artificial intelligence and machine learning enabled voice have gathered steam and why and where they are falling short. All of this and more is coming in about 10 minutes time. We will be back at 1:30 p.m. IST, which is about 11 o'clock in Saudi Arabia.